invite Rich Ford to come forward. So Rich is the Science Manager for Fisheries NZ within MPI, and Rich's doctorate's in marine biology, and he's worked as a research scientist and an academic focusing on coastal seafloor ecology and monitoring, and his degrees are from the Universities of St Andrews and from Auckland. So great to have Rich here talking about science to inform climate change impacts for New Zealand seafood. Please welcome Rich.
Thank you, Scott. Thanks for that intro. I guess I'm in some ways a poor replacement for, originally the invite went out to Dan Bolger, who's the DDG of Fisheries NZ. He was unable to make it. So as these things work in government, it's trickled down to me. But I guess the reason he was asked is because climate change is an issue that faces us all. And the thought, I guess, we're asked because of the seafood sector adaptation strategy, where we've already made some gains and we've spent quite a lot of time thinking about how we might react and getting the ducks in a row, if you like. So obviously seafood is a component of the centre. Where I sit in the organisation, we're responsible for the science we do, and that broadly fits in two camps. One is assessing how many fish are in the sea and how many we can take out of it. We call that stock assessment. And the other is how fisheries interact with the environment. So part of that is around climate change. Part of that is around environmental standards for aquaculture, how we impact the seafloor, how many protected species we capture, what's the risk to the population from that, all those sort of relevant questions. We do have some involvement with food safety, because whenever anything happens in fisheries, people bang on our door and they say, what's happening with this milky flesh snapper? You know, should we eat this? And we turn around and say, if it doesn't look healthy, you probably shouldn't eat it, no matter what the tests say while we're doing the tests. Yeah, there's been a reasonable amount of work with the Aotearoa Circle, trying to get the industry and government aligned around the seafood sector climate adaptation strategy. This was chaired by some reasonably high-powered people in the area, Dan Bolger from FNZ and Maru Samuels from the Iwi Collective Partnership. And what it does is it gets everybody aligned. It agrees the urgent need to address climate-related risks. So that's, you know, we've moved past the is this an issue? We know it's an issue. Everybody's agreed with that. It focuses on the commercial sector because, you know, the commercial sector is something like 95% of the seafood that comes out of the oceans around New Zealand. But it also recognises that recreational and commercial sectors and customary sectors, will have roles to play. And it's all about multi-sector collaboration. This is not anything we're going to solve FNZ alone or industry alone. People have to work together in this space in order to build resilience. And as we all know, climate change is a big global sort of issue. So it's thinking about, particularly with respect to the science, how do we adapt? How do we mitigate? How do we prioritise? What can we do to be prepared? So this is what the strategy looks like on a page. You won't be asked you won't be tested on the content. You probably can't even read it from there. But the things that it sort of focuses in on are assessing what the impacts are, how can we adapt, what data do we have to assess the impact. So for example, and I'll just go tangential for a moment, after the Kaikoura earthquake struck, one of the first questions that got asked was, what is the impact of this? And to do that, you've got to have a baseline to go back to. And luckily, there were plenty of baselines around there. So sort of before the crisis strikes, what information do you have to inform whether change is happening or not? Communicating, diversifying the industry to be able to cope with stresses to particular parts of the industry, management and regulatory responses. So a lot of the conversations we've had within Fisheries NZ about adapting to climate change start with, we're not sure what's going to happen. So how does a regulatory system get built or get changed to be able to be resilient and adapt quickly, which government is not known for because it's a big bureaucracy. But so how do we adapt and change more quickly than we might have had to in the past? And you see that really coming up with things like Cyclone Gabrielle, for example. That's where you have to really adapt and change. And then those questions of baselines, those questions of what can you do, how quickly can you do it, really focus the minds. So common issues for food safety in FNZ, and I suspect I'm not telling a lot of you much that's new, but maybe perhaps reinforcing it. Baselines, there will be change. How do we communicate uncertainty? It's always been a real problem in terms of fisheries, because trying to figure out how many fish are in the sea, they don't exactly put their fins up and be counted. It's tricky, and there's mathematical modelling, and there's uncertainty, and there's statistics involved, which is hard to communicate. And often it comes down to risk. What's the risk of doing the wrong thing? How do we communicate that accurately? What information do we need? Obviously, so if you're talking about, and jurisdictions get challenging when you start thinking about that. In my examples, if you think about protected species captures, is that Fisheries NZ's responsibility? Is it DOC's responsibility? Is it the fishing industry's responsibility? It's probably a shared responsibility, which is sort of how it pans out, but there's usually a lot of debate around jurisdiction. And is that slowing down your ability to respond? Along that system sort of line, are our systems prepared? It's not just the science, it's the regulatory response, it's how you're communicating between the various industries. It's how that science goes into policy or management in my sort of spaces. So it is a system challenge, not just a science challenge. And where's the blockages? Where's the restrictions? So if we're talking about aquaculture, for example, some of the blockages and restrictions there are maybe around the regulatory space, or maybe around the funding space, or maybe it's about engineering in terms of surviving the storm events. So when you're looking at that whole system, where are those blockages? Where are the things that are going to constrain progress or constrain change or constrain how you need to adapt to these things that are changing in the environment? So we've got a number of baselines. We've been, measuring the marine area for some time. I use the pointer, does that show up? Oh, okay, thank you. So this is a gradient of sea surface temperature. On the left, in the center, you're looking at acidification. Measured, the red dot is the Munida transect off Otago. The black dot is... the Munida transect. The Munida was a vessel of Otago University that went out and sailed out from Otago Peninsula out to sea and back again. And they started the first ocean acidification transect in New Zealand. And I suspect the black one here is, the black dot there is from Greta Point here in Wellington. And then on the far side, that's a plot of spawning biomass. So that's looking at a stock. I think that one's, I don't have the label on there, but I strongly suspect that's snapper. Snapper respond really positively to our warming climate until you get to Australia. And then it's warmed too much and they go down the other side of the curve and they drop off in terms of biomass. And there they're having real issues. Whereas here, most of our stocks are doing really well at the moment. But then there's some baselines that are a bit more nuanced. So this is looking at, down here is looking at a risk assessment of various bird species. And this black line here is, once you've got most of your distribution on this side of the line, it's suggesting that you're going to get a decline in the population over time. And that could be because of a number of things. That could be because of fisheries risk. That could be because of habitat. It could be because of changes in their food source due to a change in climate. So you've got baselines and you've got baselines. So often the physical baselines are quite relatively easy to measure. I'm not saying they're inexpensive or not technically challenging, but you can do that. It's just a question of having the resources to do that, but trying to figure out the impact of those baseline changes in terms of biology is another step in terms of complexity. So we know some of these things. We know New Zealand's warming at about 0.2 to 0.3 degrees per decade. Sorry, I'm talking about the water here because I'm a fisheries person, which is one of the fastest rates in the Pacific. We know this is not a uniform thing around the coast. We know it's warming more at the north, and the bottom temperatures are warming faster in the south because the water is stratified and there's different water bodies going on. We know ocean acidity is increasing, and that affects things like shell formation for juvenile shellfish. It also affects things like coccolithophores, which are a form of plankton in the Southern Ocean, which other fish feed upon. And we know that primary production around New Zealand has been in decline since about 2019 as a result of the warming. And a lot of the fisheries productivity is around key locations. The Chatham Rise, for example, is where a lot of the deep water fisheries tonnage comes out of in New Zealand. That in the sub-Antarctic. And we know that has both positive and negative impacts. So it can impact positively on the rate of growth or negatively on the rate of growth. We've seen range expansions, and I'll talk a bit more about these in a minute. Abundance can increase, particularly if recruitment's favoured. Particularly if juveniles growing into adults is favoured by the right environmental conditions. And you can get loss of key prey or habitat. And I'll go on to speak a bit more about each of these, just to sort of underline the point. So you get these biological changes. How do they impact on the industry I work in? Aquaculture, a lot of it seems to be about siting. If you put your aquaculture farm in the right place, everything else is a lot easier. Sort of like hiring people. If you get the right one, everything else that follows on is generally a bit easier. So there's issues there about siting and infrastructure, which is why there's been a lot of interest around the south end of the South Island, for example, in salmon farming, because that's where climate change impacts are going to be the least, because it's the coldest water for things like salmon. You get impacts on fisheries, productivity and distribution. I've talked a little bit about snapper. For example, Hoki, our biggest fishery, recruitment doesn't go quite so well with warming. So you've got both positive and negative impacts there. You get stronger storms, so you get more runoff and damage. Again, think your Cyclone Gabrielle type scenario, your forestry waste getting washed down into the coastal areas. Talked a little bit about range expansions. There's decreased productivity for certain animals. They don't do so well when the water's warmer. Red cod, blue cod, and paua are some examples there. And you get invasive species increasing, things like Calliope, which is the photo right down the bottom, blanketing the seafloor. And it's not necessarily that Calliope wasn't here before to some extent, but it does better when the water's warmer. So therefore you get those invasive incursions up near Great Barrier Island and those sort of areas up north. So you're a sciencey crowd, this shouldn't be telling you much that's new. Most animals have a thermal tolerance curve. So if you're at spot A on the thermal tolerance curve and the temperature increases, you're probably going to increase in abundance. If you're in spot B, you're probably just about in the optimum spot in terms of the amount of abundance. If you're in spot C and there's an increase in temperature, then things are going to go downhill. So some of the time you can alter that curve though. So when you think about the biological response, so that's what some of the salmon selective breeding work has been doing, thinking about, can we shift the population so their thermal tolerance is better? So they have increased by a couple of degrees the range over which the salmon feed. It's a work in progress. You know, there's not going to be one silver bullet towards that, but it can help to mitigate some of those effects. So when you're thinking about this, I guess it's useful to think about both the positives and the negatives, because there will be both. In most scenarios, I struggled about the positives for more damaging storms. But when you get warmer water, you know, salmon in the Marlborough Sounds struggle, particularly the adults in the summer, in the shallower waters, why there's so much interest in open ocean aquaculture. Estuarine shellfish, you get declines and you get increases in long-spined urchins, which are of concern because they go deeper than our kinner, our usual urchins, and impact on other species. On the plus side, you get more tuna in our waters, and there might be new species to exploit. The greasyback prawn, which doesn't sound that appetizing, has now got resident populations in places like the Kaipara Harbour, and people are talking about potentially exploiting those. Obviously, I've talked a little bit about Hoki and snapper and how they do, relatively speaking, in terms of the water temperature. Productivity is predicted to decrease, and that's because a lot of our large fisheries are associated with cold water. So one of the ways that we can mitigate the impact of that is rather than trying to fish to targets that assume, need to think about how to explain this. Rather than to say that we need to fish so many thousands of tons, we might say if the population changes and it goes up, we'll fish some more. And if the population changes and it goes down, we'll fish some less. So a percentage-based target rather than absolute-based target. So we're trying to move to that, particularly for some species like snapper, who we know fluctuate a lot with climate. Current changes are a real question mark due to warmer waters. We know we've seen extensions of things like the East Australian current. Nemo saw it, but Tasmania is seeing it as well down there. But yeah, if something like the subtropical convergence, which runs across the top of the Chatham Rise, if that starts changing, that will mean major changes to our fisheries. Now, nobody's suggesting that significant change there. We have seen fluctuations in the last few years, and we're watching that with interest. So with the warming water, there's some species that become more at risk. So hoiho is at the extent of their range. We've put some closures in around Dunedin for set netters around hoiho, but most of that population's down at the sub-Antarctic islands, so it's at the edge of its range on the mainland. And as warming happens, it will continue to be a challenge for them. Equally, we're capturing more leatherback turtles in the last 5 years up north than we used to because of that range extension, them coming further south. And some species may become less threatened by unintentional captures as their population increases. I couldn't think of an example, and I asked a few people, but I wait and hope. And I've talked a bit about more damaging storms. So I've talked a bit about this being a shared challenge. One of the things we're doing in FNZ is trying to get a vulnerability assessment. So the idea is there will be lots of challenges. Which ones are going to be most important? Where should we prioritise our effort? Where should we put it into in terms of our limited research funds, for example, or our management responses? So I've talked a little bit about selective breeding for salmon, quicker ability to change catch limits. Part of the Fisheries Act amendment at the moment is around having more agility, the ability to change things more quickly and sometimes with less information, because there are stocks that we haven't changed for decades because we haven't had the information base to change it because we set a really high information bar in the current Act. Multi-threat risk assessments. So in our scenario, sorry, I was thinking about the seabird risk assessment I had down here earlier on the slides. What is the most important thing we should be tackling in terms of a protected species? Is it actually about fishing? Is it about toxoplasmosis? Is it about habitat loss? Is it about their prey? And that some of those changes are harder to deal with than others. And some of the mitigations, it's often hard to attribute change purely to climate change because often it is a mix of different things that are causing the change. So some of the mitigations are useful not just for climate change, but they can help address other issues as well. So how relevant is this to food safety? I'm not science. I'm not sure. That's for me to speculate and for you guys to have a more informed opinion of. But I talked to some people in MPI, in food safety specifically, and we talked a little bit about the Vibrio example. In 2019, that led to a lot of hospitalizations from raw uncooked shellfish. This is predicted to increase with warming waters. And genome sequencing helps determine the strain and sometimes the source. So I don't know the answer to any of these questions, but I thought it would be worthwhile just putting them out there and seeing if anybody did or wanted to think about these things. So the sort of questions I would ask from my experience, is there an agreed strategy? Can the industry work together? Do we have good baselines? Can we monitor it? Can we measure it? Is there additional science we should be prioritising before we need it, rather than having to respond reactively? Can we predict prevalence and impacts? Is that going to change over time? How appropriate are our animal product notices in terms of monitoring temperature and the time for harvest? And can we respond quickly enough? Should new methods be investigated? Is our legislation fit for purpose in terms of the changes in the world? So I will leave you with loads of questions and hopefully you've got loads of answers. But happy, I don't know how this session's working, but happy to take questions if we've got time.